Stand by for broadcast.
You're listening to InsideAIR, a behind-the-wire view of the Royal Air Force, its people, technology and operations.
Hi, I'm Flight Lieutenant Chris Sully and welcome to the latest RAF InsideAIR podcast. In this week's episode, we look into the future of aerospace medicine.
One of the hazards that we're particularly concerned about in high-performance aviation is the risk of G-induced loss of consciousness, or G-LOC.
3, 2, 1, now.
And the really important question, did you need the vomit bag?
As you'd expect, we'll also reheat a few stories which could have slipped under your radar, and we'll be finding out who's under the hat this week with AS1 Ben Russell.
What's the best thing about your job?
The wide variety of engagements and locations you get to perform at. Iconic venues such as the Royal Albert Hall, Birmingham Symphony Hall, as well as taking part in big parades like the Lord Mayor's Show, the Royal British Legion Festival of Remembrance and various sporting events.
While scientists and engineers develop the RAF's 6th generation combat aircraft, a specialist team of aviation and space medicine consultants are working hard to mitigate the effects flying the aircraft will have on the aircrew's bodies. InsideAIR's medical correspondent, Wing Commander Sarah Charters, went to the centrifuge at RAF Cranwell to meet the team working on this challenge and to find out the future of aerospace medicine.
Hello, I'm Wing Commander Sarah Charters, a flight nurse with 4626 Aeromedical Evacuation Squadron. In episode 86, we visited the Centre of Aerospace Medicine at RAF Henlow to look at saving lives in the air. Today, we're at CAM's facility at RAF Cranwell to talk about the future of aerospace medicine. Before we meet with Group Captain Christian Mears and his team, let's have a chat with a student pilot who's about to take a spin in the centrifuge. I'm here with Flying Officer John, who graduated from MIOT in February 24. And Flying Officer John, you're here today to experience the centrifuge. And while we're talking, we're watching one of your colleagues from Cranwell actually going through the centrifuge experience himself. How do you feel watching him on the screen?
It's quite entertaining, but it's getting me a bit worried for what I'm about to go through in a few minutes. But he seems to be having a good time. So, we'll see how it goes.
What have you heard about going in the centrifuge?
Well, we had a training day the other back on Thursday at Henlow, so been briefed up on why we're doing it and kind of what it's going to mean later down the line for our training and when we're going to need to use it and stuff. So it's just kind of basically checking, I think, that we can meet the baseline standard for what we need to do in flying training.
And I understand you'll be experiencing G-force when you're in the centrifuge.
Yep, yeah. So I think we're going up to 5 today, but with no aids or anything. So supposedly we've chatted to a few of the other guys on course at the moment that've been through it, and they've said it's good fun. But some had a better time than others because some were a bit unwell. And
I can see your colleague there looks like he's undertaking some manoeuvres. Is that to stay conscious?
Yeah, I think so. So this is what we were taught on Thursday. We've not really had a chance to put it into practice yet, but he's pulling some good faces. So,
can you talk me through what he's doing?
So he's basically like squeezing all the muscles in his legs and abs, and then breathing out against his throat as well, so it's closed, so he's pushing out. And
on your first go, it sounds like the experience is quite short. Did we hear just now that you experienced the 5G for about 15 seconds? Yeah,
so I think the workups it was about 3.5, then 4.5, then 5, and they basically build it up so you get an idea of what you're doing, and then the first 2 is basically, like they were saying, like moving your arms around and stuff to see what your body feels like under G, and then the last 2 are basically the doing the full pass-fail standard that we've got to meet to go and do flying training.
Having watched your friend on the film, how are you feeling about going in yourself right now?
Excited, but I'm hoping I can pull some interesting faces like that at the moment. But yeah, we'll see how it goes. I'm looking forward to it.
I'm certainly looking forward to speaking with you once you've come out, just to see how it was in reality.
Let's, without further ado, move on to the assessment event then. This will be 5G for 15 seconds with a full AGSM, as good as the one you've just done, please. Sure. You need any longer to catch your breath, or are you good to go? Good to go. Dave, you have control. Hey, we're going right, 5G for 15 seconds. He's coming on in 3, 2, 1, now. Yeah, breathe normally, but put the muscle tense on. Hold on. You're done all the way. And relax, well done. I have control. Okay, so as you found out, it is indeed hard work, but any grey out or any visual changes there? All good. Alright, you've done what you need to do. That's got you the mandatory tick in the box. We can call it a day there, or if you like, we can give you control of the gondola and see how you get on when you're generating the flight control inputs.
I'll have a go at that, please.
Of course you are.
We're back with Flying Officer John. You've just come out the centrifuge. How was that for you?
Yeah, fantastic. What a cool thing to be able to do for a job. Yeah, it was great. There was a simulator in there, so it was like as if you were flying a plane, which was really, really cool. So yeah, having done a bit, it was really, really good fun.
And physically, how did it feel for you when you were experiencing 5G?
It was really, really hard work. So I was surprised because we both do quite a lot of sports. I thought we'd be quite fit, but I'm quite warm after that. So it's really, even though you're only doing 15-second bursts, so it makes you think when the guys and girls are doing that for real, when they're doing minutes at a time and then constant cycles of it. It's really, really hard work. So yeah.
So what did you feel in your body? What changed in your body when you're experiencing the centrifuge?
It's kind of like, at first it's kind of like a bit of a roller coaster when you go around and turn on a roller coaster, but it's just sustained for like 15 seconds. So it's like, first it's like, oh, this is pretty cool. And then you realise suddenly your vision's going a bit and you're like, oh, cool, I'm doing something wrong here. So you do the technique and then it comes out, yeah. It's pretty cool because you can see your vision go. And then as soon as you get the tense on, it comes back, and it's really interesting to see. Like, yeah, luckily I didn't get to the other end of it and your vision goes completely, but no, it's really, really good fun.
And did you feel safe in there? Did you ever want to press a stop button and get out?
No, it was good. It was really good fun. I didn't want to get out, to be honest. It was great. So yeah, it's like not every day you get to do something like that. So it was really, really cool.
And the really important question: did you need the vomit bag?
No, all good.
Well done, you.
All good this time.
Glad to hear that. Thank you. Well, that looked like quite an interesting experience going through the centrifuge. Can you tell me more about what just happened for the students?
I would love to, and I've actually assembled here in the room some experts that can really take you through it. So I'd like to hand over to my colleague, Wing Commander Nick Green, who will take you through what just happened.
Hi, yes. One of the hazards that we're particularly concerned about in high-performance aviation is the risk of G-induced loss of consciousness, or G-LOC. And this happens in simple terms when the G-force causes a reduction in blood supply to the head, which can make you lose consciousness. Obviously, there is then a risk of the aircraft crashing into the ground. It's also not a great combat tactic if you're trying to fly and you're unconscious. We teach the pilots a straining manoeuvre called the anti-G straining manoeuvre, and that, together with their anti-G equipment, keeps the blood supply going to the head, keeps them able to fly and to fight. It looks like it's a simple manoeuvre, but actually it takes a bit of practice, takes a bit of coaching, and the student you've just seen, that was his first go at high G, and just really at this point we're trying to embed the basic technique for them so that they can go away and practice it when they fly, make it so that as much as possible it becomes a subconscious manoeuvre for them, so that every time they pull G, a part of their brain remembers that they've got to tense their muscles and do this breathing manoeuvre.
And can you ask the students to actually practice it on the ground as well?
We don't get them to practice it on the ground, partly because it doesn't really feel the same. It feels quite unnatural on the ground. The G-force makes it feel different. The weight on your limbs and on your chest makes it feel a different sensation. But also what we're trying to do under G is restore head level blood pressure back to where it should be. If you do that at 1G, where the G isn't trying to reduce your head level blood pressure so much, you can actually risk putting your head level blood pressure up too much, which might be hazardous to your health.
And of course, we're here today to talk about the future of aerospace medicine. And I understand you and colleagues in the room have been working with the Tempest programme. And I wondered what new things are coming about in terms of management of G-force through Tempest.
Yes, that's a good point. So the centrifuge is well known for aircrew training widely, but what's probably less well known is that about half of the time on the centrifuge is spent doing test and evaluation work, physiology research, equipment trials, and Tempest is the, in theory, the Typhoon replacement aircraft, which will be coming into service in around about 2035, 2040. A couple of technologies on from Typhoon. And what we're trying to do is improve, amongst other things, the G protection in that aircraft. The reason really being to get to the same level of G protection, if not slightly better, but also with a much lower burden on the pilot, and a burden in terms of the weight and cumbersome equipment that they've currently got, and the thermal burden associated with that, so how hot and sweaty they get. Probably best to introduce my colleague Joe Britton at this point to tell you in a little more detail what that work's about.
Thank you very much. So as Wing Commander Green said, what we train people here is this anti-G straining manoeuvre. And whilst it's a really good technique to do to raise your head level blood pressure, there's a couple of issues with it. First of all, you've got to do two different things at different times. You want to constantly tense all your muscles, and then the breath strain is actually an intermittent one. So it's a bit like rubbing your head and patting your tummy. You're trying to coordinate two different actions, and through practice, you can get very good at that and do it almost automatically. But still, doing that is taking up a little bit of that mental capacity. And the other thing is you are using all of your muscles all the time that you're pulling G, so it gets quite tiring as well. So the problem is it's fatiguing. You can be distracted from it and not do it as well, and it can distract you from your other primary flying tasks. And one of the real paradoxes of the G strain is if you get the timing slightly wrong, actually it can make your G tolerance worse. So it's really important to get it right. So it's a good technique, but we could do better. And what we're aiming to do in the future is reduce the reliance on that anti-G straining manoeuvre for G protection, with the ideal goal of making sure that our protection is good enough that no one ever has to do a G strain, but that's still probably somewhere over the horizon. And by doing that, we then free up that extra bit of mental capacity for our pilots to focus on their primary task, reduce that fatigue, particularly for those long flights. If you're doing a lot of air combat, that's all going to build up over the sortie as well. And one of the other things we want to do, as Wing Commander Green mentioned, is not just improve the safety of the G-suit, but also improve all those other aspects that impact how well you can fly your aircraft. So removing that thermal burden. G-suits are quite hot and bulky. There's a lot of impermeable fabrics to keep the air trapped in it. And that can make you quite hot and sweaty over a long sortie. So reducing that, and actually potentially even adding some ways to cool people, reducing the number of layers, reducing the bulk and all that discomfort that distracts from that your main job in the air.
And I'd imagine the advances in technology that you're bringing about through the Tempest programme may well benefit pilots operating on earlier platforms. Would that be right?
Yes, definitely. So a lot of this research is coming about through my PhD, and right at the start we limited the scope to air-inflated G-suits. There are other ways you can provide G protection. But by doing so, that means that anything we learn from this can relatively easily be back applied to our current platforms, as they all operate in largely the same way. And also just the underlying science that we're getting out of this research, a better understanding of, first of all, what G-suits are doing to the body, but also learning new ways to measure that and be able to compare G-suits with each other are aspects that we can apply to any platform, either past or future.
Obviously, it's really important to test future equipment within the centrifuge. Is that enough, or do you need to take the equipment up into the air as well?
Yeah, that's an excellent question. So whenever we test new equipment, be that G-suits or oxygen systems or any bit of equipment we want to provide our pilots, it tends to go through a variety of steps. The first is we look at it in the laboratory. So on the bench, does it do what it says on the tin? Then we want to take it into some simulated environments. The centrifuge is just one of those. We also test thermal capabilities, hot and cold. Sometimes a wind blast, if it might be ejected, what's going to happen to it with the big airflows on ejection, or the hyperbaric chamber, so how does it operate at altitude. But each of those are just one small snapshot of all the challenges that you get in the aerospace environment. And the only real way to combine all of those in a realistic manner is in flight. So we're lucky enough to have the aerospace medicine flight at RAF Waddington. And that gives us time on the Red Arrows Hawks to test some of this equipment, and that's an absolutely vital part of this flight testing.
Are you telling me that it's the Red Arrows pilot who tests out all the kits?
We're even lucky in that, actually, we have our own tame pilot. Squadron Leader Gaz Kennedy is probably one of the most experienced Hawk pilots in the RAF, and he's been with us for a long time, since we used to have our own aircraft, our own Hawk, which offered us a bit more flexibility. We could install completely new oxygen systems in that platform, but as time moves on, we're trying to learn how to operate in a slightly different manner.
I would imagine that there's an awful lot of pressure for the Red Arrows to be practicing and using those aircraft for their flights. How important do they feel it is for the medical flight to go up?
Yeah, I think it's one of our challenges always is to explain the importance of continued testing. I think we've had a number of decades now where the equipment has been safe. It's kept everyone safe in flight, and that safety has only improved. So it can be tempted to look at that and say, well, you've answered all the questions. What more testing do you need? But every new bit of equipment interacts with all the other bits of equipment and the aircraft slightly differently. So it all has to be challenged and checked in flight to make sure we maintain that level of safety and can achieve the improvements we want. So it's on us really to make sure that we can communicate that as best as possible and fight those other demands of time. There are lots of demands in the Air Force, so we've got to show why our job is important too.
We've talked about the work you've been doing around G-suits for Tempest, for that project, but I just wondered, how early have you got involved in the Tempest programme? Is it really important for you to be there from the beginning, working with the engineers to make sure that medicine is considered right from the outset of the project? So is it important, and have you actually managed to do that?
Yes, it is absolutely vital. And I think as a good example of that, I'll hand over to my colleague Wing Commander Posselt, who's been doing that in the helmet-mounted display area.
Yes, this is one of the unique aspects of aerospace medicine, which is the interaction with engineers and trying to develop the human in the loop from an early stage. And it sets us apart from your more traditional doctors treating patients with diseases and aches and pains. And this is something, particularly with the Tempest programme, that we're getting in there early enough so we can optimise the platform and make it suitable for the people that we want to be able to fly it, rather than traditionally you buy a piece of equipment and then try and put the human in it, and sometimes that human doesn't fit or it just doesn't work too well.
So what does that mean in reality? What kind of research are you doing within the Tempest programme?
So with me particularly, part of my research for my PhD was looking at vision standards, particularly in the context of a more visually demanding cockpit with displays and helmet-mounted displays as well. And looking at informing the evidence behind our medical standards. As the aircraft have changed and become more digital, our medical standards haven't necessarily since the advent of flight. So do we need to update those medical standards? And in order to do that, we need to better understand the capabilities of the human by having more repeatable, more reliable tests. And when we have evidence to inform medical standards, we then have the ability to alter the medical standards, either make them a little bit more lenient or make them more stringent in certain aspects. And that may be something going forward that we then end up having potentially medical standards that differ depending on the different platforms. So having a broader entry medical standards, but in the vision realm, for those more digitally, visually demanding platforms, having slightly more stringent ones specifically for those.
Does that mean that for some medical tests, we might, rather than having a yes-no answer, you're fit or you're not fit, there may be a spectrum, and then we're quite person-centred, and we make sure that the individual is appropriate for the platform they're operating on.
So I think we'll always need to have a set medical standard for entry, a line in the sand, but after that, once someone's met an appropriate evidence-informed medical standard, it's very beneficial to know exactly their ability, and in order to do that we need to have reliable, repeatable tests to do that. And with that information, we're able to better monitor people throughout their career, so we can get in earlier for appropriate investigations if needed. We can better support people's return to flying, and we can also then track performance with the different standards or the different measurements, and that then helps inform equipment procurement as well, to set requirements when we're looking at procuring new bits of equipment. So yes, a more individualised approach, and we could then with new equipment say specify it to an individual. So someone with a particular colour deficiency who is above the standards, we may be able to personalise a display that has greater luminance for that set individual. And that's just one way looking forward that we may be able to update our policies by looking at the evidence behind standards, and then personalising equipment to individuals.
And is your work just about pilots and aircrew, or does it benefit the wider Air Force?
So we look after a whole spectrum of the military. In the aerospace medicine, as in the specialty, the specialists, we focus more on the aircrew. I'm going to hand over to the Command Flight Medical Officer, Wing Commander Flick Leeming, who can talk a little bit more about that broader aspect of it.
Yeah, so my job, I'm a GP by background. My colleagues are aerospace medicine consultants. So my job is to look at individuals and their particular medical issues, and then look at how we employ them in the environment they work in. So that's not just aircrew, and by aircrew we're talking about people flying the aircraft with the controls, or people operating in the back of the aircraft like loadmasters, crewmen, or int analysts, linguists in the back of various different ISTAR platforms. So our medical standards, we have to encompass all of those individuals. But the research that my aerospace medicine colleagues do also helps to inform how we look at ground crew as well. So as Bonnie was talking about some of the visual requirements, well actually that might map across to an engineer on the ground using some kind of computer screen, or how we look at standards for that as well. So it very much, we're aircrew focused, but a lot of the research will then apply to other individuals within the military as well, and wider as well.
And a big focus for the RAF at the moment is retention, and I guess that means that one of the things you need to think about is the impact of ageing in the aerospace environment.
Yeah, absolutely. So you're right, it's one of CAS's top priorities is to retain. So for us, that means we want to retain aircrew for as long as possible and keep them flying as long as possible, because we're able to keep that experience and those qualifications for as long as possible. As much as we don't want to admit to ourselves, as we age, certain areas will degrade. So vision is classic, hearing, reflexes, and our physical performance will degrade as well. So one of the areas we want to do some research into, and really that's ideally placed with a GP who has that more sort of operational and disease focus, and the ASM colleagues who are looking more at physiology, is to understand what those degradations are, how we can best measure them, and how they will impact on flight, because each individual will be very different, and some experience will offset some of those degradations. So an older, more experienced pilot with some issues might be able to handle a situation slightly differently to a newly qualified pilot who isn't used to dealing with that aircraft. Equally, we want to look at how we employ that individual as well. So looking at that role-specific area and layering all of those bits of flying that maybe we don't appreciate can be slightly separate pressures on that aircrew. So looking at how they're flying in an operational environment, in a training environment, in a hot environment, a long sortie, a high G sortie, or a very load-focused sortie, or for example, for somebody in the back of a helicopter. That then gives us a better idea of the information we give to the duty holder, because ultimately it's the duty holder that decides whether they're going to fly that individual or not. As doctors, we give advice to the duty holder about an individual, and that's my role as the CFMO. But the more information and the more understanding we can give that duty holder to understand the risk of flying that individual on that particular platform, in that particular role, in that particular environment, the better of an informed decision they can make about that person, that individual. And the more we are able to use that individual for longer, and perhaps that cross-covering or swapping between different platforms, the more we can do that as well with more understanding of that.
And just for clarification, when you say the duty holder, who do you actually mean?
So the duty holder is the person responsible for that aircraft, so be the Typhoon Force Commander or whoever is responsible for those aircraft. They're best informed to make that decision.
It sounds like there's an awful lot of complex work that you need to undertake to fully understand the impact of agent, for example. I'm just wondering, how will you actually find time to do that, and what are you doing to work that one out?
So I think that's an interesting area we're trying to lead in with at CAM, really, because I think there's a lot of research that needs to be done in that area, and how best we articulate that risk to the duty holder in the chain of command, because at the minute it's quite difficult to do. We have quite an old-fashioned way of calculating risk called the 1% rule. I'm not going to get into it. It's really complicated, and I'll dig myself into a hole. But that's a risk of incapacitation in flight. I think what we need now, with the multiple different platforms, multiple different roles we have, and a more modern approach to risk, then understanding how to articulate that risk better with those subtleties would be much more useful to the duty holding chain. So we're hoping that we'll be able to get some funding for research into that area, and that would be a GP that would hopefully do that, because it is that interaction between disease and the platform itself.
It sounds like that would be a really helpful development to retain future pilots and other aircrew.
Yes, absolutely. Really important work we want to do.
One of the things we're seeing at the moment is a lot more activity for remotely piloted air systems. And I just wondered, what's the future in terms of aerospace medicine for RPAS pilots?
So yeah, when we're looking at something like RPAS that's really expanding in both the civilian and the military world, one of my jobs as CFMO is to understand any risks and trends that are being reported to the MOs on station or to the duty holders, and obviously from our civilian or international military colleagues. So I will try and identify anything that comes up that way. But one of the interesting parts we've noticed from RPAS is some of the visual standards. So I think that's probably an area that Wing Commander Posselt is better to talk about. So I'll hand you over to her.
Linking back into some of the vision standards we spoke about earlier and the medical standards, as an example of changing, evolving medical input, is we have actually relaxed some of the vision standards for our older presbyopic aircrew, so those aircrew that require reading glasses, which happens as we get older. And yes, so that's an example of where med has had an impact on the ability to retain aircrew in that role.
We hear in the media concerns sometimes expressed around the mental health and well-being of RPAS pilots. I just wondered, what's the future for mental health and well-being, not just perhaps for RPAS, but also for some of the fast jet pilots?
Yeah, so that's an area we definitely keep an eye on, looking at trends, referral rates to mental health support, and obviously input from our MOs on station and from the squadrons themselves. So we do keep a close eye on that. I think one of the things we try and do as a whole is to optimise the performance of aircrew themselves. And that's not just looking at mental health, it's looking at their nutrition, hydration, health, fitness, all of those areas, because really what we want is our aircrew to be fit on entry to the Air Force, but to maintain that fitness and health throughout their time within the Air Force. So we'll try and input on things like nutrition. We'll try and advise on how best to and what type of exercise is best for that particular platform. It's not so helpful doing long endurance exercise if you're flying in a fast jet for various different reasons. So we'll advise on that as well. The other part we look at is in trends with aircraft is the ACP, or the aircrew conditioning program, was brought in to help reduce the incident of musculoskeletal injuries, particularly in fast jet crews. But some of the physios out there are looking at how we adapt that better to suit people, the crewmen on Chinook, for example, or on some other platforms as well. So we're constantly identifying trends and issues and trying to improve the general health of our aircrew. And clearly that obviously impacts on our ground crew as well. So we'll try and identify any of those trends to help with the ground crew too.
Thank you. Moving on, and perhaps back to the Tempest programme, I wondered if you could tell me what else is RAF CAM doing to prepare pilots and other aircrew for the future operating environment?
Yes, of course. So I think generally when we think about the future and medicine, things, bits like Elon Musk's Neuralink and plugging in directly into people's brains and cybernetic suits, etc., come to mind, and drug-enhanced soldiers. The reality is perhaps a little more, I won't say boring, but a bit more simple than that. Particularly in flight safety, we have to make sure that whatever we're going to apply is going to be safe in the long term. So all of these very front-edge technologies will take a while to get into the air because we've got to make sure that they're safe at ground level and aren't going to cause complications in flight. And with all those other challenges that the flight environment puts on any changes in technology. So really, whilst it might sound more simple, what we're wanting to look at is how we can improve performance and remove what we are starting to call this idea called margin degraders, and we've mentioned it a couple of times already. Probably the best way to explain that is with a bit of a scenario. So say imagine you're sat on a Teams meeting, sitting down for a 5-hour meeting. You're running a bit late, so you didn't get that cup of coffee before you sat down. About 20 minutes in, you realise you're a bit under-caffeinated and you've already lost a little bit of that margin of your cognitive power. So you're not operating at 100% anymore. And then about another 30 minutes in, your dog starts barking in the room next door, and that's a little bit distracting, so it takes off maybe another 5%, and then you remember they were unwell yesterday, so now suddenly you're more worried, and that's taking a bigger chunk of that capacity. And then 3 hours into your 5 hours meeting, you really need the toilet, and suddenly you've had those slight small degrades on your performance, but now about 80% of your mind is just thinking about how you can get to the toilet without interrupting that meeting. And all of those things are just chipping away at your performance. You're not operating quite at your best. And all of those are challenges that our aircrew are facing in an aircraft as well, often with far less simple solutions to those. So really what we're focusing on is trying to remove those as much as possible and allow our aircrew to operate as in their peak performance throughout flight. I'll hand you over to Wing Commander Green to discuss some of the ways we're looking into that.
Thanks, Joe. Yeah, I think the way to think about this is just to think about some of the environmental stresses that you come across if you're flying a high-performance aircraft. We've talked about G, about acceleration already, and Joe's already described some of the work we're doing to manage the distraction associated with performing the G strain. But more simply, noise in an aircraft can be quite distracting, as well as being a potential risk to your hearing. It has an effect on cognitive performance. And if we think of the future aircraft operation, we think of Tempest as we have done, we're probably thinking of longer missions. And longer missions means more noise, more distraction, and a longer period for which you've got to concentrate. So trying to improve the noise environment of aircrew is certainly something we're interested in. Other environmental stresses include, of course, the risk of hypoxia. We've said that hypoxia actually with modern systems is quite rare because the systems work pretty well, but there's still always a risk of a very small, subtle amount of hypoxia if your mask isn't quite fitted, if you're taking your mask off, as we talked about last time, if maybe you've got facial hair, can allow a little bit of cabin air in, and that might cause a very subtle degradation to your performance that you wouldn't necessarily notice, but actually could affect your decision making. Similarly, both ourselves and the US are actually quite interested in the quality of the airflow, and it sounds like a strange thing, but breathing on a mask is not a normal thing. Even if a pilot, you get used to it, it's not a normal thing. It feels quite different to breathing in our everyday lives, and the character of that breathing can sometimes be quite distracting, and so we're both working US and UK on trying to improve the standards associated with that, so we deliver more transparent breathing flow. Similarly, hot and cold, it can be very hot in the aircraft cockpit, particularly if you're doing physical work. And so improving the burden, as Joe's talked about, of the clothing and the cooling mechanisms associated with that is certainly an area of interest. We also mentioned desperate to go to the toilet during the Teams meeting. Same issue for your long duration flight. You need to be able to both eat and drink to maintain your performance. And if you've been drinking, then you need to be able to let that out again. And so in-flight urination devices, although it sounds somewhat crude, are quite technically challenging, and an area that we really want to optimize going forwards.
One of the things I'm really interested in is the cognitive overload that pilots might experience. And I'd imagine that as we move forward through different generations of aircraft, that cognitive requirement must be going up and up. How do you think we can mitigate those risks?
Yes, I would certainly agree that pilots will always really work to their cognitive maximum. And I think if you talk to a Typhoon pilot, they would say the cognitive load in the cockpit is extremely high. And the way that the workload is managed is partly by the human-machine interface and the teaming of the two. This may change in the future as some of the roles performed by the pilot are in controlling remotes, controlling drones, and having more of a kind of a dialogue with the computer rather than directly controlling it. So we may see elements of AI, of artificial intelligence in there, but at the moment it's more of a question of how the system displays information to the pilot and what information it chooses to display and chooses not to display. And this is a really difficult area. You can easily overload a pilot by giving them lots and lots of information. You can use a system to try and decide which information the pilot needs at that particular moment, but that's a really difficult thing to do, and it certainly risks the system hiding a vital piece of information that the pilot actually wants, which then increases the pilot's workload as they have to go into the system, into a submenu to try and find the thing that they were just looking at, that the machine has decided to not show them. This isn't really our area of work. This is very much this is an area the industry is working in. It's very much occupational psychology. It's human-machine interface work, but will be critical going forward. And as I say, what we're trying to do, I guess, is reduce the physiological distractors that limit that dialogue between the human and the machine.
Thank you. Now, looking much further into the future, Wing Commander Posselt, I understand you've been learning more about the potential impact of hypersonic flight on the body. I wondered what you can share with our listeners around this area of aerospace medicine.
Sure. One of the roles in the specialist wing of aerospace medicine is to keep our ears to the ground for future technologies and kind of horizon scan of what could be the art of the possible. And hypersonic vehicles, the ability to travel really fast, to get anywhere in the world really quickly, would have a potential military benefit of being able to transport troops anywhere. And recently, the RAF Cam were invited by the UK Space Agency to a workshop hosted by the European Space Agency looking into the feasibility of these types of vehicles. And it's apparent that the aerospace medical considerations really are the limiting factor for these things. It's really difficult to travel fast. The forces on the body, the G-forces, the risks of being at such high altitudes, and the life support systems that you would require to wear in these vehicles and in the event of an emergency are really pretty limiting. So this is a future capability. Currently, UK Space Command do not have a ambition for human space flight, but with the potential benefits, this may be something that they look forward to in the future, and we will just keep our ears to the ground about that.
We've heard today there's so much going on in terms of the future developments for aerospace medicine, and we've got learned colleagues here who've undertaken PhDs. We've heard about potential for further research around primary healthcare. I just wondered, as the boss of the Centre of Aerospace Medicine, how do you actually prioritise what research is undertaken and where you concentrate your efforts?
So we very much have a multi-layered approach to this. We have a weekly meeting where we all get together as a team to work out what's going on across the team at CAM to see where we need to put our resources if in case something comes in fastball last minute that we need to get on top of. From that at a local level, we then go out, we have our various research committees up into Air Command itself where there's a cohering mechanism. So should there be some competing demands from outside of CAM that we can actually put it all together and go, right, that is our priority going forward. One thing I'd like to get after the conversation that we've had today is actually what isn't going to change in aerospace medicine in the future. And very much what makes aerospace medicine is being intercollegiate. So you've heard that we have psychologists, ergonomists, engineers, physicians, surgeons. I could go on. That is not going to change. We still need that whole panoply of professions being involved and going into the future. Also, our international colleagues. Now, our main focus is regarding NATO, Five Eyes, but also other nations that we are very closely aligned to. Tempest that we've spoken about, certainly with Japan and Italy, and likely others moving forward, where we have that international approach with all our colleagues. And certainly using this podcast, I'd make a call to any of them listening that, hey, we're here to help, we're here to partner with you, and that's very much what we want to make aerospace medicine in the future the absolute place to be working.
Now, I wondered, just as a final question that I could pose to all of our interviewees here today, just imagine that you're a 10-year-old listening to the podcast and you want to be aircrew in the future. What could you do now or over the next few years to prepare for that?
So it's Flick Leeming here. I would advise, as a GP, advise staying fit and healthy, keep yourself well, keep exercising, and hopefully you'll be fit and healthy for the duration of your career in the Air Force.
For me, I really recommend trying to get an introduction to flying. So join the cadets when you're at school, and when you're at university, try finding out your university air squadron. It's a really fantastic way of meeting like-minded people and getting to do some actual flying.
Hi, it's Nick Green here. I think he or she should consider being a geek and a nerd, I would say that, but get behind the science. The whole thing is getting much more complex technologically, so get involved with things like the Aeronautical Society, go to air shows, but try and understand what's actually happening in the cockpit, because it is changing.
And I think for myself, jumping off that point, the cockpit is changing. The traditional role of the pilot is changing. It's going to be a lot more about monitoring multiple systems at the same time, interacting with machines. So it might sound odd, but I think one of the keys to a good pilot in the future is a good gamer of today.
So, Christian here, I would certainly say anyone wanting to be a pilot or any role in the Air Force of the future is to be curious.
Now, just as a final point, we talked in the first episode about the prospective move of RAF CAM from RAF Henlow to RAF Cranwell. We're here in a really beautiful setting and very modern building. The centrifuge looks amazing. I just wondered what's happening next in terms of the move.
So, as we've alluded to already, CAM is going to be the last facility at RAF Henlow, and from 2026, CAM will actually move up here to Cranwell. And very much with the planning process going on, I hope that it will be seen by those generations coming through in the future to be co-located with the centrifuge in the field right next door, so that the Centre of Aerospace Medicine will be together as a whole for the first time in about 27 years by the time it comes to fruition, which we as a team are very much looking forward to, and I hope that those future aircrew coming through recognise all the hard work that's been done by my colleagues around me and of the wider team who've served in CAM over these last 3 or 4 decades.
Group Captain Mears, our Command Flight Medical Officer, and colleagues who are aviation and space medicine consultants, and indeed the entire team at the RAF Centrifuge. Thank you so much for your time today and talking with InsideAIR and our listeners about the future of aerospace medicine.
Thank you.
This is Reheat for InsideAIR, where we take a look at some of the RAF stories you might have missed. I'm AS1 Emma Kerwin. The Prime Minister's paid tribute to the RAF Typhoon pilots who intercepted Iranian drones which were fired at Israel. The fighter jets shot down a number of drones on the 13th of April. Rishi Sunak has praised the pilots' bravery and professionalism, saying they're flying into the face of danger to protect civilians. Next to Romania, where the RAF and Spanish Air Force have worked together in a joint training exercise. Typhoon pilots simulated an air-to-air attack. Flight Lieutenant Wilkinson says it's important to work with other NATO allies to share techniques.
We did an OCA SA, so it was a stealth-escorted strike mission into fake red territory to try and take out some targets. The Spanish were playing red air so they were trying to get in our way, whereas myself and the instructor, we were trying to get into the Badlands and drop the bombs and then come back safe. It's not something we routinely get to do back in the UK, so it's good to get out here and work with other nations.
6 RAF Typhoons and more than 200 personnel from 140 Expeditionary Air Wing are currently co-leading NATO's enhanced air policing mission in Romania. The RAF will hand over to Spain later this year. A brand new building for hundreds of RAF air cadets has officially been opened at RAF Little Rissington. It includes a new accommodation block, crew room and shower facilities. Once the home of the RAF aerobatic team, RAF Little Rissington's been used as a site for gliding, as a parachute drop zone and periodic training ground by units and aircraft since 1994. And the RAF Coningsby-based Typhoon display team have revealed a newly painted display aircraft in D-Day Invasion stripes for the 2024 season. You can check out what they look like on the official Royal Air Force social media accounts. That was Reheat for Inside Air.
Cheers, Emma. And now it's time to find out who's under the hat with Ben.
I'm AS1 Ben Russell, and this is Under the Hat, where we get to know an aviator in less than a minute. Name you're known by.
I'm Corporal Joe Kemp.
What's your profession?
I'm a musician in Royal Air Force Music Services. I'm currently based at RAF Norfolk, and I'm working as part of the media and communications team at RAF Music Headquarters.
What's the best thing about your job?
The wide variety of engagements and locations you get to perform at. Iconic venues such as the Royal Albert Hall, Birmingham Symphony Hall, and many more, as well as taking part in big parades like the Lord Mayor's Show, the Royal British Legion Festival of Remembrance, and various sporting events.
Best location you've served?
As part of RAF Music Services, we get to travel to several overseas locations such as Cyprus, Italy, Gibraltar, Australia, and many more, as well as performing in large events closer to home, including the Royal Edinburgh Military Tattoo and the Belfast International Tattoo.
And what's your proudest moment in the RAF?
I was fortunate enough to be one of 2 bass drummers for the state funeral of Her Late Majesty the Queen. We both then went on to receive commendations from the General Officer Commanding London Districts for our contributions on bass drum again to King Charles III and Queen Camilla's Coronation Parade.
Thank you, Corporal Kemp. That was music to my ears. You never missed a beat, and you even ended on a high note. An all-round great performance on Under the Hat.
So that's it for this episode of Inside Air. Please give us a review, it really does help. Subscribe via your favourite podcast app and join us again soon.
You've been listening to Inside Air, a behind-the-wire view of the Royal Air Force, its people, technology and operations. If you're serving in the RAF and have a story for us, please speak to your unit media and communications officer. Inside Air is written and produced for the Royal Air Force by RAF Media Reserves.